let's talk about adding enough products into a game or application. This isn't something new, but still a lot of new and experienced developers have issues with it when it comes to the implementation. This is why it's so popular to choose third-party APIs that will deal with everything under the hood and give you a simple and intuitive cross-platform API, as well as guidelines on how to use it. It seems like a good option, right? It is, as long as you understand how it's working. And here's the reasons why. First, it's about your money. If the plugin you choose will have flaws that will allow users to get some products for free, it will go straight out of your pocket. The second one, the worst experience user can have with your application is to pay for something and not get rewarded. In this case, it's pretty much 100% that you are going to lose the paying customers and get a one-star review. Long story short, the solution you choose and your implementations has to be able to handle all the edge cases possible. But you're probably not going to use the server side to implement enough products into a game. And it could be quite a few reasons why. You don't have an expertise to implement it, you can't afford to pay for the server, you don't want to spend an additional time on it and want to just release your application as soon as possible and test it. Which brings us to an interesting point. Both in-app APIs from Apple and Google are designed to be used along with the server-side implementation. That means that every non-server-based implementation would have flaws and may not handle a lot of special cases correctly. And just a reminder, it's about your money. Every flaw in the implementation is a potential revenue loss for you. So how to check if the third-party solution you are using isn't server-based? Have you configured the server-to-server API for your game and provided the authorizations case to the plugin? No? Then no server-side involved. And to be completely honest, I would be very skeptical to authorize some third-party solution for this. So I see two options here. First, you can pick a plugin that will give you access to the native API directly, like iOS native or Android native. The only difference is that you will use C# instead of the Java or Objective-C. Or you can rely on third-party solution, but only if you completely understand what kind of issues may happen and how the plugin will try to resolve it and what kind of issues could not be resolved by a plugin. So getting back to the Ultimate Mobile, is it a server-based solution? No, it's not. Will it handle most of the edge cases? Yes, it will. It will handle every single case that is possible to handle without having a server side to provide an additional data. If you want to use the Ultimate Mobile cross-platform API and also add an additional security level by implementing your own server side, you can still do this. The plugin will provide you with all the required data for your server to be able to validate the transactions and request an additional info about purchases. With that said, let's see how to implement the cross-platform non-server-based solution that is able to handle most of the edge cases. And in the next videos, we will talk about each platform in particular, what and how Ultimate Mobile can handle without server backup, and what cases cannot be handled without server-side for each platform.
So let's review the in-apps implementation based on this game. Well, not really a game, it actually just gives you an ability to buy some skins for a turret and buy some ammo, but if you want to spend some money, hey, I guess this can be considered as a game. This simple project will be available on a GitHub, so check the link below. Let's assume you have already configured your project inside the Google Play console and iTunes Connect, so we will only focus on the implementation. If you want to see another tutorial of how to configure everything, just let me know. It should be pretty much straightforward, but there is like few steps that are rather confusing and people tend to have issues with it. Okay, so the first order of business is to configure your products inside the plugin. This is important because you can't just connect to the payment service and say I want to buy this product by this ID. It won't work. I will explain later why. Let's start with iOS. Open the Ultimate Mobile Services tab, pick the in-app purchasing service, and select the iOS plugin. Here is where we can add some products. Then just go ahead and copy your products from iTunes Connect to the plugin settings. What's really important to set here is product ID and product type. Everything else will be overridden once you will be connected to the actual payment service. So you might think, why do I have an extra fields then? Well, a few reasons. First, you can keep it for your reference, and second, this information is actually available in a runtime, so you can display it to your user before you connect it to the payment service. You can of course choose to display a warning instead, something like connection to the payment service is currently unavailable because, well, user would not be able to purchase something anyways. And for example, this sample application will only display products once connection to the payment service is established and those products can be purchased. Another small feature that you can actually assign an icon to the product, which can be pretty convenient feature, and this is something that I will use in this tutorial as well. Once you're done with an iOS settings, do the same for an Android. And do not forget to enable plugin for the platforms as well. Another thing you might be curious about is why do you have to do it twice? Because you pretty much set in the same products for the both platforms. Well, that's not always the case. You can have an exclusive products for different platforms. In my case, for example, I only sell red turret skin for an iOS and green is only available on an Android. For those of you who prefer to do everything by code, you can still do this. You just need to define your products lists and then use that list as a parameter to the connect function. And that's about it, what you should know about defining your products. Let's jump to the implementation. So this is my game payment service. Let's go step by step of what I'm doing here. First, I need to get my app service client and set the transaction observer. The transaction observer is actually the most important part here. It will process successful and failed transactions, will perform a validation and reward a user for a purchase, and will do pretty much everything that is connected with the transaction processing, so we will review it in a bit. The next thing I'm doing here is trying to connect to the payment service. If connection is available, I will fire onServiceConnected event to notify the rest of my application that we now have a connection to the payment service. If connection wasn't successful, I will just show an error message to the user, and I will also store the connection state with my isConnected flag. In this sample application, I have this left panel that will display available skins for my turret and will allow me to purchase them, and will also display the state of already purchased skins. Now let's see how it works. First of all, I will set the text to the login message because I don't know if I already connected to the payment service or not, because I'm not sure if by the time my game UI controller started, if connection to the payment service was already established or it's not. So if it was connected already, I will just go ahead and refresh my skins options. If it's not, I will subscribe to the onServiceConnected event and refresh my skin options as soon as I will have an active connection with the payment service. The refresh skin option method will set skins title to skins, and since all my non-consumable products are turret skins, I will create a skin option button for each non-consumable product I have. There is also an interesting addition about product is active flag here. It will indicate if this product is actually recognized by a payment service. So if it falls, it means that there is some kind of issue with this product and it wasn't recognized by a payment service. Probably the ID is wrong, or product is not cleared for sale yet. Anyway, there is no point of displaying this product in a store because user would not be able to purchase it anyway. Now to the add skin option method. It will create a new skin button for each non-consumable and active product. The new skin button will be configured based on product icon, product title, and product locked state. We will also assign a listener to the button click, and if this product is still locked, then we will add payment to our payment service that will start a purchase flow for this product ID, and if it's unlocked already, then we will just set skin for our turret based on this product ID. You may also notice that I'm not using a plugin API to find out if this skin is locked or not, like if this product was already purchased by a user. And this is because the plugin does not provide this kind of information for you. The reason for this, I simply do not have a cross-platform reliable way to get you this info. So you will be responsible for storing non-consumable product states on your own. And this is more about the experience you'd like to provide to your users. You can store it locally using player prefs like I did here, or you can use some kind of cloud service to store it, or probably even your own server implementation. I also have an ability for user to buy some more ammo to play with by clicking on Add Ammo button. The implementation is a lot simpler here. As soon as button is clicked, I simply start in a payment for my 10 ammo pack item. You might also notice that Add Payment method does not have any callback. This is because all payment is handled in the transaction observer, and handling the payment can be a quite long process. It can even be started in one session and will be finished into the other. So it's good time to go and review the transaction observer implementation. You need to create your own transaction observer and implement iTransaction Observer interface. You will be prompted to implement onTransaction and onRestoredTransactionsComplete. Let's take a closer look at onTransactionUpdated callback. First of all, you need to analyze the transaction state. The restored and deferred, those states are specific for iOS, and we will talk about those later. The failed state means that while transaction is failed, it can be cancelled by a user, or in general something is just went wrong. So in my case, I will just unlock the screen and finish the transaction. You can get more information on what exactly went wrong by analyzing transaction error object. The purchased state means that user has already been charged and it's time to reward the user. So here is how I do this in my process complete transaction method. So there is my rewarding mechanism where I will analyze the product ID, and if that's an ammo pack, I will just add more ammo, and if that's something else, because every other product I have is actually skins, so I will unlock that skin and will display a thank you message for the user. After that, I will unlock the screen and will finish the transaction. Worth mentioning that I'm not performing any additional tasks here, like server validation for my transaction or sending it to analytics or whatever else I need to do before I can feel comfortable rewarding the user with that item. But you can totally do this, and if you want to learn how to get all the required information from the transaction, you can check out the advanced use case article. Now let's talk about something that may not be that obvious. Finished transaction should be a very last step when you're processing your transaction. The reason for this, if transaction isn't finished, system would not allow user to purchase the same product if, let's say, this was a consumable product, and if your application is crashed during your attempt to reward the user or performing any other tasks between user has purchased the item and transaction is finished, such transaction would not be lost and your observer would receive onTransactionUpdated callback on the next application launch. Which gently brings us to another point. Your onTransactionUpdated implementation should be ready to process the transaction at any given period of time, because you can't know when exactly you will get this callback. Well, most likely it's going to be once the user has finished his purchase flow, or if your application is started with some pending transactions, but just to be on a safe side, be ready to process your transaction at any time. By the way, if you have few pending transactions, be ready to receive a few onTransactionUpdated callbacks, so that's something you should also be aware of. And one more tiny note, do not forget to finish failed transaction as well, because it will behave pretty much the same way as successful transaction. It will lock your product and it will be keep coming back to your application until you finish it. The onRestoredTransactionComplete callback is specific to the iOS, and we will get back to it once we will review how it works on iOS. And that's pretty much it. That's the whole implementation. Time to see how it would work in Unity editor on Android and on iOS. We would also try to emulate the potential issues that may happen during the purchase flow, and we'll see how the current implementation would handle it. Okay, so we were able to load the store, fire some bullets. Let's now try to get more ammo and unlock some skins. We're not gonna test any special cases here, because when we're running into the editor, we're not actually connected to a real payment service. And editor emulation is just for you not to get blocked when you're testing your game in the editor. It will pretty much respond with a success result for any API call, applying a small delay. Time to test on the real Android device. First, let's make sure that our normal flow works absolutely the same way as we have seen it in the editor. So we can fire some bullets, get some ammo, and also able to unlock a skin. Now to the interesting part. Let's try to buy our blue turret skin and try to crash our application during the purchase flow to make sure our application wasn't able to process this transaction. As soon as we will launch application again and connect to the payment service, the lost transaction has to be restored and we still would be able to provide a blue turret skin to a user who already paid for it. The next common use case we're gonna test is what is going to happen if I will reinstall the application or will install it on another Android device I own. Google Billing API allows to retrieve transaction history records. Plugin can take advantage of this and restore non-consumable items transactions that wasn't yet processed by this application local copy. As the result, as soon as the fresh copy of our sample application is installed, blue and green turret skin will become available. And it's time for iOS. Let's get some ammo, fire a couple of bullets and try to unlock and apply skin, just to make sure that our application functions properly and we can go to the special case testing. So the first special case we're gonna test is to crash our application during the purchase flow and to see if transaction can be restored on the next application session. So I will stop an application from the Xcode in the middle of my purchase flow. An interesting part that I can still finish my transaction when application is no longer available. Well, this is kind of expected because iOS payment service is not attached to my application instance. Anyway, I can now launch an application and make sure that my purchase wasn't lost. The next case is to be able to restore non-consumable purchased items when you reinstall the application or installing it on another device you own. According to Apple policy, if you have non-consumable items in your application that can be restored, you should have the restore button inside your store API, which should start the restore flow. So let's make one. I will place the restore button inside the skin's store interface and will make sure that it will only appear when we're running on iOS platform. The button implementation is quite simple as well. All I have to do is to call restore completed transactions method. Before the restore flow would start, user might be asked to enter his credentials, like before the actual purchase. This is the reason why you should only call restore transaction method when user is ready for this and explicitly press the restore button. During the restore flow, your transactions observer will receive transaction update for every non-consumable item purchased by a user. All transactions will have the restore state. In the end of the flow, your observer will receive on transactions restore complete callback. So let's see how it works. I will press the restore button and I will have my two skins I purchased earlier restored. Well, that's it. That's how you do it. But I still encourage you to check next videos to be fully aware how the native APIs are working and what is happening under the hood of the ultimate mobile cross-platform implementation.